Trinity, I think you can also admit folks.
Beautiful, I can do that.
We'll get started in just a minute here. Hi, everyone. Welcome to an Out2Lunch webinar sponsored by the Education Committee of the Earth Science Information Partners. This webinar series are 10-minute demonstrations of Earth Science data, tools, and resources with 5 minutes afterwards for Q&A. And you can always view our presentations at our webpage on the ESIP fed.org website, or you can also go to our YouTube playlist and view past webinars, including one today. And with that, I'm going to hand it over to our speaker today, Trinity Foreman, who will introduce herself and share her screen.
All right. Hello, everyone. Thanks for joining us today. I am going to drop a quick link in the chat that you can go ahead and open, and I'll start talking and you can do that in the background. But let me get set up really quick. All right. So my name is Trinity Foreman, and I'm a communications consultant with ICMS at NOAA's National Centers for Environmental Information. And today I'm going to share how to use NCEI's new Tsunami Events Time-Lapse animation tool. So NCEI is a trusted source for the history of tsunami events worldwide, with over 2,500 events since 1650 BC archived and stewarded. And this information is accessible through the Natural Hazards database, but the new time-lapse tool provides a way to understand the frequency, size, and source location of tsunami events from 1850 to the present time. So the link that I shared with everyone is right up here too. So make sure you have it open and everything's ready, because I'm going to do a quick demo and show you how to use the tool, and then also some possible ways to bring it into the classroom. And at the end, if I go pretty quick, I'll try not to, but we also have a web story that explains a lot of the things I'm going over that you can look at for reference as well. So first off, when you first open the web page, it will look like this. Depending on your monitor size, the map might look different. One of the easiest things to do to fix that is to use the zoom in feature right here. It's the plus symbol up in the top left corner, and the zoom out feature. So go ahead, and the first thing you do is get this set to your screen. That'll make your life easier. At any point too, if you're zoomed in really close and you're moving around, because you can use the hand feature to pan. If you want to get back to the home screen, you just click home, and then you go right back to that first screen. So that'll make your life easier. The other thing to notice is over here in the right-hand side, this helps you explore the occurrence of tsunamis, and this is the time-lapse element of it that I was referring to. Also, it looks like, Carla, there's 3 people in the waiting room. It just popped up. I don't know if you see that. But,
I think I admitted them.
Okay, just checking. Google Chrome likes to give little alerts like that. All right. So to play the time lapse, you click play, and it'll run through the tsunamis that have happened since 1850. So if you let this play on its own, it will run for about 3 minutes. So a great way to really visualize this data in a timely fashion, but there's other ways to interact with it. You can also pause it at any time. Sorry, I said to zoom in and then I zoomed out. But you can pan through these months using the arrow features as well. And this will go, this month right here and year is what you're displaying. And you can pan through those and go by month to see a certain event if you know one, or to look just at a certain month. Something else to notice, if you scroll all the way to the end, which would take 3 minutes to get to, you see a lot of icons. This doesn't mean that all of the icons that are showing means these are all the tsunamis that happened in 2020, which is the end of this timeline. What is happening is you're seeing the brighter icons are the most recent tsunami events. And if you scroll through, or if you're playing the animation, they flash as they occur. So that can help you depict them while the animation's playing, knowing what's happening. All right. Also, something, if you're curious about any certain event, you can scroll around, and for example, this event has a very large dot. You can click an event and it will pull out data about the said event. So some of the data you will have is earthquake magnitude, if it was an earthquake that caused it, max run-up event, which you see here, that is the wave that was created by the tsunami, and then event validity. An event validity is particularly important because it shows how certain scientists are that the tsunami event occurred. So we have records going back in this to 1850, and the validity of tsunamis is based on several factors. For one, tsunamis recorded on tsunami gauges generated by earthquakes recorded on seismographs have a very high validity. So historical events before the invention of seismograph or tide gauges require looking at if the damage was recorded in multiple locations, or at the number of reliable independent sources citing that the event happened. So the database of events that this relies on too is continually being updated as new research is published, even if on older events. So new information can increase or decrease the validity of a tsunami from hundreds of years ago. So something to keep in mind when you bring these up with students is that this event validity shows how important data is for scientists to understand what's going on and having lots of sources. So a great resource for teaching source material. If you scroll back to the end, or not the end, to the closest time period, 2020, you will see a representation of all the tsunamis since 1850. So this key in the upper right corner, it shows you what type of source event caused each tsunami. So circles are earthquakes that cause tsunamis. And as you can see, the majority of these are earthquake-caused tsunamis. You can also see volcanoes are the triangles, squares are landslides, and the diamonds are tsunamis with unknown causes. So also, the size of the icon symbolizes how deadly each event was. And we have a key for that as well. Over by this first key I showed you, the second box down pulls up a legend that will show you approximately how many deaths were caused by each size icon. You can also pull that information up individually, like I showed you earlier, and they show you the amount of deaths recorded in this first box. So that's more precise, obviously, than the legend. So as you can see, most of the icons are the circles, because 81% of tsunamis occur because of earthquakes under large bodies of water. But 11% of tsunamis are caused by landslides. So either caused by earthquakes along rugged coastlines or in regions with glaciers. So if we were interested in seeing only tsunamis caused by a source event of a landslide, we can filter this data as well. And how we do that is we go to this top right corner and toggle on these buttons. You click all the items that you want to exclude. So we don't want to see any tsunamis caused by earthquakes, by volcanoes, or unknown sources. And then we see all the tsunamis caused by landslides. So can anyone, you can say it in the chat, spot any trends with how this data is occurring, or where these landslide triggered tsunamis are occurring. And Carly, you might have to be my eyes.
Sure.
Thanks. I'll give you a hot second because I have so much I want to cover. Okay, no worries. I'll skip right to it. With the changing climate, a lot of these landslide triggered tsunamis are the result of increasing temperatures, can create these glacial retreats and melting permafrost. And as you can see, in northern regions where that would happen, but that's not always the case. As you can see, there's some in the ocean over here, but a lot of them are further north. So as I take off these filters so we can see all of them again, they all come back. It is important to note that the icon location does not mean that all areas affected, does not represent all the areas affected by a tsunami, but is showing where the source event occurred. For example, off the coast of Chile, right here, a historic May 1960 tsunami occurred off the coast of southern Chile, and that had impacts across the Pacific Ocean. So if I was to scroll back to 1960 to try and see that occur, you see that large flash. This is the tsunami I'm talking about. So if I pull, sorry, there are multiple that happened around that time, as you can see. So this is the very definite one. This is the one I'm referring to, and it has lots of death. So this tsunami individual, or this tsunami in particular, was formed by the largest earthquake ever recorded. So it's not surprising that the event validity for this is a definite tsunami, because there's lots of documentation. And the 2,220, the number, sorry, I'm running over my own words, does that, that captures all the deaths from Chile to the Hawaiian Islands and Japan. So it's not just saying all of the deaths happen in Chile. So it's an important thing to consider when you're looking at this. Since this is such a well-documented tsunami as well, we have lots of references talking about how we know this happened and what was seen in different locations. And we even have a travel time map of how quickly that wave moved across the ocean. So there's lots of resources and a lot of these well-documented tsunamis you can pull from. I'm going to switch back. If anyone has any quick questions while I have this up, go ahead and ask them now, because I'm going to switch gears in just a second to more of the teaching element of it. Is anyone having issues with using this?
We're a small enough group that if you want to raise your hand and unmute to ask a question, that's fine. We do have, as an extension, have you considered showing the areas impacted like this old illustration? Shelley has a link in the chat there. Not sure if you can see it, Trinity. Here, I'm going to let Shelley speak.
Okay,
I'll go for it. Yeah.
Thanks. And this is really cool. I've come across this now multiple times. But the kind of the flip side to this is showing the sources, and the illustration that I'm showing is an older image showing where places along the Pacific Rim states have been impacted. And so it's a little bit probably harder to show in a map format, in a live map format like this, but I was just wondering if that might be an extension that you guys have considered and in the future.
We have some of the scientists who've worked on this on the line. I won't put them on the spot right now. I'll let them think about it. But I will say that this is one function of what we have for data viewers. We also have the natural hazards map viewer, which has a lot more information, and you're able to filter things a little differently. So the impacts of, like I know we have, I think, run up in that as well as a filter. So, but this is really to show the time scale of it. And I'll have that link in the last slide I can throw into the chat. Does that answer your question though? this briefly?
Yeah, because I mean, there's a 2016 article that shows like number of people impacted and deaths. I think it's from NCEI. That was really a wonderful illustration. Um, and anyway, I'm just thinking with my Shake Alert hat and being able to earthquake early warning and showing how important it is for folks to realize that earthquakes far, that happen further away can also have large impacts on the Pacific Rim, United States, as well as around the world. So thank you.
Yeah, no
Trinity,
problem.
Beth has a question.
Yeah, go for it, Beth.
Hi, this is just sort of a user observation. So I was, and by the way, this is super cool. I'm very excited about it, but just trying to think of helping, people use it as easily as possible. So I'm looking just at the landslides and I'll click on the little square to find out about that landslide. But the first 5 times I did it, I actually got information about an earthquake, which was apparently invisible because must have been like logically on top layer wise. So I had to super zoom in order to actually get the information about the green square. So I don't know if there's a way to make earthquake information not show up at all, if the earthquakes are off filtered at that time. But super cool. You can work around it. I just could see students getting confused on that, for instance.
No, definitely. I see your point there. Nick and Lindsay, do you want to say anything to that? You're more than welcome to if you want. If not, we're good. Okay, no pressure. Yeah, I think too, another feature I've noticed in that, if you do pull up multiple, like I'll show you what I was talking about. I think, yeah, you can still see my screen. When you pull up multiple like that too, a quick tip for the students, if like, for example, there were a lot of events that happened in Southern Chile around this and they aren't sure if another tsunami happened and that sort of thing, you can see right here, 1 out of 5, you can flip through the multiple events in that without zooming in too close. But I do agree that the earthquake could be confusing if you're just trying to show the landslide, but sometimes it can be a multiple source event too, like maybe they're together and they're not sure which one, but that's the clearest I can answer that for you. But that is a good tip for if you're not zooming in and you want them to see multiple events and get to the right one, this feature can go through multiple events in that very specific location without having to like re-click a small little circle. So, but thank you. I'll bring that to Lindsay and Nick to make sure we can integrate that. Anything else before I move on? These are great questions. I really do appreciate it. I do want to show you something else before we change gears to complete Q&A, because I want to also bring up that this is a great tool for talking about plate tectonics or plate boundaries and things like that. It's not just talking about tsunamis. For example, since so many, that the active regions of the plates also include, that makes things that have more earthquakes and but also volcanic activity, you can use this to illustrate that impact. For example, if you're looking at the Nazca plate right here, right off the coast of South America, if we're trying to have the kids guess, okay, which do you think is a convergent plate boundary? Which do you think is a divergent plate boundary based off of the characteristics we know? They could see by the earthquake activity that caused these tsunamis that this would be what you would guess and what is the convergent boundary. So just something to think about, that it doesn't have to be just tsunami education. It can also be applied to more geology inclusive education. That is mostly what I was going to show here. This last slide is more resources, and I'll throw them in the chat if we have any more Q&A. But NCEI has a lot of geology focused resources that we encourage you guys to use. This tool, I've had a great science team that's been really wants to get this out in educator hands. So I feel very fortunate for that. So we also have this detailed description of how to integrate it into lesson plans. That is the second link that I'm going to throw into the chat. So I really hope you guys use it. It's hopefully it's made to be used. So please use it and please share it. And I'll take any more questions if anyone has anything. Oops. Okay, I'll throw those links in. The first one is the NCEI education page where we have more resources. And the second link is the teacher guide I was just referencing. Has some great pictures too to go along with it if you're trying to teach with this. And then the last link is something we reference, which is the natural hazards viewer. This has a lot of capabilities of filters and things like that. So if you feel a little more comfortable with data viewers, definitely something to pull into the classroom, but something you should probably lead rather than the kids having at it.
We'll be posting the presentation slides with all the links as well after the webinar, along with the recording.
Awesome.
I just wanted to sort of second Shelley, you know, that this picture that you have showing right now, which shows the effect from, you know, at least super important tsunamis is super valuable, you know, and I could see that maybe just for a relatively tiny subset of them, like if you were able to integrate a pop-up or something that would be like, this is what it looked like, you know, if it's too hard to like animate it on the map, you could be like, here's an image, you know, for anything that, you know, for maybe all the very great big ones or something like that, is powerful. And I'm glad, it's awesome that you've combined it in the teaching resources for at least certain ones, I guess, too.
Yeah, definitely. And this image actually was pulled up from that natural hazards viewer, that third link I provided. So you can manipulate it to show you this. But yeah, for those more significant events, I think at this point, like for example, that 1960s one, it's provided as a link, but I see what you're saying, where having that visual element in there would be helpful. Sorry.
So it is a link in there. Okay.
Yes, right here. Tsunami time travel map right here.
Oh, okay,
So
great. So that's
that's
exactly
cool.
it. That, yeah. So for ones where we have it, essentially, I'm assuming.
Exactly.
Which
Yeah, so
doesn't
for those
necessarily
ones
tell
that-
you where people were killed over there, but you can, you know, hypothesize where they might have been affected.
Exactly. And this one shows you that time, it shows you how quickly it moved to. So something you could pull into the classroom pretty easily. Yeah, here it is. It pulled it up.
Oh yeah, yeah, that's awesome.
Yeah, so that's embedded in it, but that was the best format to do it for this. Anything else?
Just a quick question. Are these hours?
Sorry,
yeah.
hours. I thought you meant like hours. I'm like, yeah, this is mine.
Hours in this illustration here.
Good question. See, Lindsay said yes.
Yes. Okay.
Awesome. That's why I have them
Cool.
online.
Yeah.
They're the super experts on all of this.
Yeah. No, I really like this, and because it kind of echoes some of the other viewers that are out there, it really helps lower the bar to entry for instructors who get overwhelmed with so many different viewers and so many different ways to work things.
Yeah.
So that really helps. My only comment on the turning on and off the color, you know, the layers, it's always hard to know what's on and what's off, like, because this is dark is on, right? So if you click on earthquake and now it's off, it's kind of hard to know that that means off. So I don't know if, you know, just as a user feedback, thinking
Okay,
about
yeah.
like, say the word off, you know, something like that.
Or a hash line across
Or a
it,
hash
that would
line.
really clarify it a ton.
Awesome. That's good feedback. Yeah, I'll bring that to them. I think that's a good point.
And it's really great to see all these. And so one of the things I was thinking in the future is like, you know, you have that big event, Chile, and you're showing its progression against the ocean. And it's like the places that had the highest run-ups, it's like, well, why? And, you know, so one of the things we're developing is, you know, factors of inundation. It's like, well, here's an example, like, why did that particular bay? Well, because the water could just run right in. And really impact.
Yeah. It's a good point.
So, well, thank you for this presentation.
No problem.
jazzed.
Have fun playing with the data.
Yeah.
And I do, if you like doing this kind of thing too, for more layers of run up and things like that, I definitely suggest looking at the natural hazards mapper. It's a lot of fun to play with.
Yeah. Oh, Peter. I know him through other climate stuff. Cool.
I'll just mention that next Wednesday, Peter will be presenting on the Globe Observer Land app, tree app. So we're looking forward to that. And that will be next Wednesday, noon Central. And I'll have it's the same registration site, which will be up later this afternoon. And you can register to join us next Wednesday. Does anyone have any last minute questions for Trinity?
Can you pop that site with the registration in, because I got emailed the link to join, so I don't know where people registered.
I will send it to you. Right now, the registration page still has Trinity's information on it. I'm waiting for Peter's title, and then I'll email it to you, Beth.
Okay, thanks.
Sure.
Trinity,
Well, thank
A lot.
were you thinking of expanding the education resources as well? You know, because you're talking about the other applications in other realms.
Sorry, you said Trinity. I'm just checking.
Yeah.
Okay.
Yeah,
I was
back
like,
to
I think
you.
this is what. Okay, good. Just checking. Yeah, I've been trying to add some resources for a lot of the different tools NCEI has, but I'm open to it. I think right now it's in a point where I need to move to climate for a little bit and then maybe come back. But I do want to add some resources to help make this approachable for sure in the future.
Okay.
So if you have ideas, shoot them to me. I always like to brainstorm, especially for outreach.
Great. Thank you.
Yeah. And thank you guys. I really do appreciate your attentiveness and good questions.
Thank you so much, Trinity, and everyone who joined. Hope to see you next Wednesday.